So we are going to do an example of graphing one cycle of cosecant. So we have y equals 2 cosecant 1/2 theta. And so remember that cosecant is the reciprocal of sine. And so when I graph this, I'm going to do all of the stuff just like regular for sine. The only thing that will be different is when I actually graph it. Right? So I'm going to start off with 2 sine 1/2 theta. Right, that's what I'm going to start with. 2 sine 1/2 theta. Deal with that, and then the only difference will be when I actually make my graph. And so what do I have going on here? I'm going to go ahead and list out everything I know. I know that my amplitude is 2 because of the number in front. My phase shift, or horizontal shift, I don't have anything added or subtracted to theta, so I don't have one, so none. I don't have one. I do have a change in my period, though, right? I have this value multiplied to theta, so my period is going to be 2 pi over 1/2. Remember, when we're dividing by fractions, multiplied by the reciprocal, so this is actually 2 pi times 2, so my period is 4 pi. Well, that comes in handy finding all of our points. And the last one, the range. What is the range of this going to be? I don't have a vertical transformation, so I'm not sliding it up or down. I'm just multiplying my values by 2. All right, I'm gonna leave that off, but we do have. I guess I'll write it. My range for sine, it's not going to be the same as the range for cosecant, but I'll go ahead and write it for sine. The range would be -2 to 2, because I'm just multiplying my values by 2. Right, just changing my amplitude. All right, so I know I have stuff that's going to affect the y values. I have stuff that's going to affect theta. So let's go ahead and work on them. All right, so I'm going to do the y values first. All I'm doing is multiplying my y values times 2. I'm not adding or subtracting anything to my function. So if you recall the original values for sine, 0, 1, 0, -1, 0, and I'm just going to multiply all those by 2. So 0 times 2 is 0, 1 times 2 is 2, 0 times 2 is 0, -1 times 2 is -2, and 0 times 2 is again 0. So there's all my y values. It's the easy part, right? So my theta values. Do I have a phase shift? No, right, no, I don't. And so my starting point is going to be the same. It's still at 0. But I do have a change in my period, right? Instead of my period being 2 pi, it's 4 pi, which means it's going to stretch out my graph. So to find my other 4 points, I'm going to take the period and divide it by 4. So 4 pi divided by 4 gets me pi. This one turned out pretty easy. So I'm just going to add pi to my starting point to get my other 4 points. So 0 plus pi gets me pi. Pi plus pi is 2 pi. Plus pi is 3 pi. Plus pi is 4 pi. Okay. So I got all my theta values, all my y values. So now comes the graphing. I actually want to graph cosecant, so I'm just going to plot my points to begin with, right? Just going to plot my points to begin with. So pi, 2 pi, 3 pi, 4 pi, and I'm going up to +2 and down to -2. And again, just plot your points. So 0, 0, pi 2, 2 pi 0, 3 pi -2, 4 pi 0. So my center did not change, right? I did not have a vertical shift, so my center was still 0. So I have vertical asymptotes at my center. So I'm going to put them in red. Can we see them? Kind of. So at all the points that are on my center, I have vertical asymptotes, just like that. And on the high notes, I have open upward parabolas. And on my low notes, I have open downward radius. And so there's my graph of cosecant. All right, and you can pause that or come back. I'm going to go ahead and do a graph of secant just for sake of time. And so same thing, I want to graph one cycle of y equals, let's say 3 secant theta minus pi plus 1. I'm going to graph this. So 3 secant theta minus pi plus 1. And remember that secant is the reciprocal of cosine. So secant of theta is actually 1 over cosine. And so I want to start by finding all of the values for cosine. And then again, the only difference will come when I actually graph it. So I'm going to start out finding cosine. So what do I have going on here? I have a change in my amplitude. My amplitude is 3. I don't have a change in my period, so my period is still 2 pi, right? And I know that because I don't have anything in front of theta, right? It's just 1, so my period is still 2 pi. I do have a phase shift. Remember, the phase shift is going to be my starting point, so that is very important. My phase shift, remember, horizontal is opposite, so I'm going to the right pi. And I also have a vertical transformation, trans, and I'm going up 1, which will affect my range as well, right? It'll affect the y values. And so I'm just going to start with cosine. So theta, we'll figure out our transformations. Y equals 3 cosine theta minus pi plus 1, right? I want to find all the values for cosine first before I graph it. So let's start with the y values. If you look at the function, I'm supposed to multiply the original y values times 3 and then add 1. And if you recall, the original y values for cosine, are 1, 0, negative 1, 0, 1. So I'm going to multiply by 3 and add 1. So 3 times 1 is 3, plus 1 gets me 4. So 3 times 1 plus 1 gets me 4. 3 times 0 plus 1 gets me 1. 3 times negative 1 plus 1 gets me negative 2. 3 times 0 plus 1 gets me 1. And 3 times 1 plus 1 gets me 4. So there's all my new y values. Now my theta values, I don't have a change in the period, but I do have a phase shift. It says right pi, so I know that my starting point, since I'm going to the right pi, my starting point will be pi. And to get the 4 other values, I'll take my period and divide it by 4. So I get pi over 2, just reducing it. So this is what I'm going to add to my starting value over and over to get the other 4 quotes. So pi plus pi over 2 gets me 3 pi over 2, plus another pi over 2 gets me 2 pi, plus another pi over 2 gets me 5 pi over 2, and then adding pi over 2 again gets me 3 pi. So remember, I am trying to graph secant, so I'm just going to plot these points on the graph. So I have pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. And the highest I'm going is positive 4. And the lowest I'll go is negative 2. Oh, sorry. Y'all can't see that. Thank you. All right, so the highest is 4, and the lowest is -2. And one more time, I just want secant, so I'm just going to plot my points to begin with. So at pi, I'm at 4. At 3 pi over 2, I'm at 1. At 2 pi, I'm at -2. At 5 pi over 2, I'm at 1. And at 3 pi, I'm back up at 4. So this one definitely was transformed. Think of the regular cosine function, the original. And so remember, my center, at the center, I'm going to have my vertical asymptotes. The center is these points right here. So they are not solid lines. They're imaginary, just placeholders, vertical asymptotes. I cannot cross those values. At the high notes, I have open upward parabolas. At the low notes, I have open downward parabolas. So this one's kind of going off the page, but boop, open downward. And remember, if we want to be fancy, technically, if I'm only graphing one cycle, bam, the cycle is going to end at that point. So it cuts my parabola in half. And same thing on this side, my cycle begins at this point. So again, it cuts that left side off. I won't count off if you put the whole parabola, but you might get a smiley face and plus 0.5 points if you do the half parabolas. All right? If you have questions, of course, ask. You all have a good